All right, so welcome back. Last week I broadcasted from home, but we started on encapsulation. And for encapsulation, remember, is three things, of course. Is the grouping of pieces of data together so that you can treat them as one entity or one unit. So that, you know, if you have a baseball team, or if you have a student, or if you have, like what we were building, a film. A film is a title, running time, you know, stars, directors, whatever else is in there. You need to, a release date as well. You can encapsulate that all into one user-defined type. Encapsulation is also the protection of that data. But unfortunately, that's more of an object-oriented programming language concept. So that is supported in Java, but it's not supported in C. Likewise, number 3 is also supported in Java, but not supported in C. It's the grouping of functionality that acts on that data. You group that functionality with the data. Now, that's not to say that you can't achieve both of these things in C. It's just that you kind of have to bend over backwards because C is not an object-oriented programming language. In order to get the protection of data, you'll often see the convention of beginning member variables with an underscore. That's just a signal to outside folks to don't touch this variable, right? It's private. If you touch this, then it's undefined behavior. You can also get number 3 by basically doing function pointers, which is something that we'll get to later on. But again, it's not really object-oriented programming when you do that kind of stuff. But that is how like the early versions of C++, which is an object-oriented programming language, basically extended the behavior of C to get that kind of stuff. So just as a review here, what did we do last time? We created actually 2 structures in C. A date structure with a year, month, and day, because that's 3 items. We grouped those together into one logical unit so that we could talk about dates. Then we had a film, which was a title, runtime, IMDb rating, which is a double, and a release date. In other words, our film was composed of other objects, of other structures in this case, right? Composition is when one structure or one object is composed of other objects, right? To define that, we use type defstruct. We use upper camel casing conventions on the names, date and film here. We use lower camel casing convention on all of the member variables. We then went on to do the same thing in Java, but we didn't bother with making another date because in general, what you do when you design objects is you break down what the object is into its components until it's either so simple that you can just do it, like with a number or a string or something like that, or it's already solved for you. Just like with the problem solving, right? You break down a problem into smaller and smaller parts until a part is already solved for you with an off-the-shelf solution, something from a library. Or, in this case, from the Java time library, we'll just use localdate to represent a release date. By the way, there is a date type built into C. It's date all under lowercase underscore t. Underscore t is for type. It's actually difficult to use. And I didn't want to do that in this presentation because I wanted to show you that you could have a structure composed of other structures. Yeah?
Assuming that Java's time thing is made roughly the same way we just made it here, why didn't we just use what we did in C?
Because it's already built for me. Why reinvent the wheel, right? I didn't do that in C because it is kind of difficult to use, and I did want to show at least one way of composing it over here. Again, you could have done it over here, created, say, a director, right? And then you would want to create a person class, and so that a film has a director, which is a person then. Something that would look like this, private person director, right? Something like that. And then, of course, you would have to define this class. I didn't want to go that far, though. Right? We could go that far at the end if we have some time, though. Right? All right, so when we defined, in Java we had, again, we had that number 2 of encapsulation, the protection of that data, by making all these variables private. Of course, there's also public, protected, and the lack of a keyword means that it's package protected, which is what we started out with. But otherwise, I use the same conventions as before. All right, upper camel casing for class names, lower camel casing for member variable names. Yeah?
What's the use of making everything, all the variables
because then you control side effects, right? For example, titles cannot be missing. Titles cannot be null, right? If I made this public, anybody could set a film title to null all they want, because if anybody has access to the variable, they can change that variable. And if you do code it so that any piece of code can change this piece of code, then that means that you have to test for the eventuality that every piece of code will change that piece of code and all the side effects and all the implications thereof, right? What happens when we have a title that is null? But over here, I'm not even able to do that, right? If I tried to do that, now I've got my film cats from the last time. F.title is equal to cats, or null, let's say. That's an invalid title. I'm not allowed to do that because of visibility. Again, with C, you don't have that number 2, that protection of data. A protection of data allows you to control side effects. It allows you to scope down side effects and mutations and changes to your code in the smallest possible area. It's like having the difference between a looped scope variable versus a larger variable. So for example, for int I equals 0, I is less than 10, I plus plus, right? Oops. I have scoped this variable by putting it in here so that it only exists inside this for loop. If I try to access it outside this for loop, right, then that's invalid. You want to limit the scope of all your variables as much as possible, right? You want to keep things as simple as possible so that there are less potential failure points that you have to test for. Yeah, well, from the outside world. All changes can still happen, but they have to happen inside the class, right? And we'll talk about getters and setters here in a moment. Right? But otherwise, what we did was we started by then, well, once we've got the structures defined, once we've got a class defined, we need to we need a way to create them. And in C, we created this create film function that took the title, the runtime, the Internet Movie Database rating, and the release date, and dynamically allocated a new film. Remember that we can use size of. Once we've defined a film, then the size of macro compilers are dumb, but at least they can count. They can go through and say, okay, well, that's 8 bytes, that's 4 bytes, that's another 8 bytes, that's another 1, 2, 3 times 4 bytes, that's another 12 bytes, et cetera. You add all that up, and I know how many bytes a film takes. Right? The compilers are dumb, but at least they can count. And that's why we're using this. I drove home the point that there's only one film here by doing this multiplication by 1. Of course, that wouldn't be necessary in practice, right? And then we went about setting up all the memory for the title. All we had to do was copy over the runtime, et cetera, the Internet Movie Database rating, and the release date. Remember, why did we use an arrow operator here? What kind of film do I have? I have a film pointer. When you have a pointer to a structure, you use the arrow operator. When you have a regular old structure, you use the dot operator, right? So let's note that down, right? Note the observations. That when you have a regular old structure, you use the dot operator to access member variables. Right? When you have a pointer to a structure, you use the arrow operator. And again, there are technical names here. The arrow operator is the indirect component selection operator. The dot operator is the direct component selection operator. But why use fancy words when you can use just what they are? The dot operator, of course, what does that look like? Dot, right? To access member variables. Unfortunately, this is going over. There you go. There. Now that's a hyphen and then a greater than sign. So it's an arrow that way, right? Okay, what else did we see over here in our creational function here? We used string copy, of course, title. We copied over the title, the Internet Movie Database rating, and then we returned this. Right? There is an alternative way of creating things, right? Consider the following alternative. Alternatively, you can create an initialization function, right? If you already have a structure allocated, You simply need to set its values. Right? So let's take a look and see what that might look like over here. Okay? I'll go ahead and start in film.c. It's an initialization function, so I'm not going to say that it's going to create a film. I'm going to say that it's going to init a film. Right? And you can spell out initialization if you want, but init is common enough. It's not going to return a film. You give it a film and the title and everything else, and it takes care of building that for you. So it's not going to end up returning anything. Maybe we can use that return variable to do some data validation later on, right? So let me go ahead and pass in a book B, right? And then everything else, all this stuff. Right? Right. A style, or honors, a style film.c. There. I didn't have to muck with the indentation at all, right? I let it do it for me. Oh, I should have gone over. It wasn't able to handle that, though. All right, fix that for me. Thank you. All right, there. Now, is this correct? Let's think of this not in terms of structures. Let's think of this in terms of, say, integers, something that we're very familiar with. I am passing this integer by value, not by reference. So if I make changes to that integer here in this function, b is equal to 42, does that change the original book that somebody gave me? No. Or the original integer that somebody gave me? No. It only changes that parameter variable b. So likewise, if I pass a book by value, the book gets, all the book data gets copied onto the program stack. If I go and change it, then when it gets popped off and destroyed, there's no changes to that book. So how do I need to pass this book in as a pointer? Should I make it const like I made it the title? No, I'm going to be making changes to this. I can't make it const, right? That's the correct way of doing this, okay? Let's get rid of that. Now all I need to do is set up, you know what? It looks very familiar. Copy, paste, right? But now, oh, book, what am I doing? Films, sorry, film, and F. Books was the main section, that's what we did. Sorry, if you see me doing that, please yell at me. No, we're not doing books, we're doing films. Or of course you could do students, or you could do albums, or you could do whatever objects that people are, everyday objects that you're familiar with. Yeah?
I see. You're trying to make changes to F from inside the function.
Exactly. You give me a film and its title and everything else, and I'll make sure that it has that stuff. By setting up memory and copying a string over. In fact, this is so common, maybe you want a deep copy string function like we've done before and reuse that, right? But otherwise, I'll copy over the runtime, the Internet Movie Database, and of course the release date, which is just a regular old structure, right? Release date is a regular old structure. It is not a pointer to a structure, so I don't need to dynamically allocate it, right? Copy, paste. Do you think that's a good idea? I see 1, 2, 3, 4, 5 lines repeated. DRY, don't repeat yourself. One of these could probably call the other one. Should I have create film call init film, or should I have init film call create film? Well, we have to have a film in order to set its values, right? We do have a film given to us, so we're not responsible for creating it, right? So I could probably replace these 5 lines of code with init film, and then a pass-through. Pass in F, pass in title, runtime. All right. Let me double make sure. I never checked my mic. Yeah, it's good. All right, runtime, IMDb rating, and release date. Okay, and then return F. Now I'm not repeating myself. And of course, this is a void function. I could return immediately here, right? To do, consider basic error handling and data validation. Right? I'll leave that as an exercise. What if somebody gave me a film that was null? All right, that's pretty straightforward. But what if somebody gave me a film without a title? Or maybe I want to reject any title that's missing, like it's an empty string, right? Maybe I guess you could have a film with only a single, would be as short as it gets, but maybe you could have like I or T, like T, I don't know, do you know any films with just one single letter? I can't think of any off the top of my head, but maybe that's a bad, and then of course you could enforce dates, right? You can't have a date that is more than 10 years into the future. You can't have a date that is February 30th, 1980, right? Stuff like that. You could do, and then you could use the return value here to return an error code, okay? But I'll leave that as an exercise. So, alternatively, you could have an initialization function where you already have a structure allocated and you simply need to set its values, okay? Let's see. Yeah, go ahead.
I have a question. One of your like things you said we could do is like check to see if there was a title. Would no title in having like a title be like null?
No, right? Yeah. I mean, you could say that you check that if title is null, then you could return an error code of 42 representing invalid title or something like that. Right?
Alright.
Yep. So there are other convenience functions that there are often, basic operations that you do with structures all the time. For example, you may want a way to print a structure to the standard output. You may want a way to generally provide a string representation of a structure, right? A human readable, right? Actually, no, it could be human readable, right? And if it's a film, maybe the title and then the release date or something like that. It could be, say, XML or JSON for EDI, right? EDI being electronic data interchange. Right? You have some experience with XML with that state data from last week's lab. You may or may not get additional JSON experience, but you'll definitely get it next semester where you have to serialize objects. So you have to persist them to a database or save them as XML or JSON so that they can be transmitted over a network to a different computer that may be completely different technology stack. I could be writing my objects in C and then transmit them over to another computer that is running a C# stack or something like that. And I would serialize the objects into a universal format like XML or JSON, transmit them over there. They would have the same schema, and they would be able to decode it in completely different language, completely different technology, but those two computers can still exchange data electronically. Right? That's where EDI comes in. All right, you could also have a function to free up a structure, right? This is sometimes called a destructor. Why? Because of object-oriented programming, you have a constructor. What's the antonym of construction? Destruction, so you have a destructor. Right? Let's go ahead and do a few of these in C, and then we'll talk about how to do them in Java. What about a print function? Void print film. Right? And I'll be given a film, F. I could pass this by value since I'm not going to be making changes to it, but it's way more efficient in general to pass in something by reference. Right? Why? Well, because if you pass it in by value, that means the entire film gets copied onto the system stack. Right? It's not that big of a deal with this because the film is only maybe like 40, 50 bytes or something like that. But if you get larger and larger and larger data structures that you are, data structures, data containers that are, say, a K of data, 10K, 100K, right? Now this starts getting expensive because you're copying all that stuff every single time, copying it off the stack, copying it to the return address variable, or to return address, so that you can return something by value. Forget about it, right? If you're passing a pointer, you're only ever passing 8 bytes, period, right? Usually. So I'm not going to be making changes to it, so I've created a const. Right? So how do you want to print this? Remember that it's got a title and a release date, we could print out all the information or just some of the information that we care about for human readable interaction. Right? We could say printf, %s, the title, right? And then in parentheses, we could put in %d for the year, right? Or there we go, %d, 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 right? And then end the line. And this will be f's title, f's date, or release date. And then I want year, month, day. Right? So how do I do that now? I go from a film, which is a film star, right? That's a pointer. So I have to use the arrow operator here. Once I've got the release date, though, release date, is that a regular old structure or is that a structure pointer? It's a regular old structure. So how do I access the year of release date? Dot, right? Year. And then all that again, date, or month, sorry, and day. There. Let's actually test this. Yeah, go ahead.
What makes film a structure pointer and date not a structure pointer?
The parameter that I gave makes it a pointer. F is a pointer.
Why do you need F to be a pointer?
You don't, but if you don't need it to be a pointer, but if you do it like this, then you're passing it by value, meaning the entire film gets copied onto the stack. And I want to avoid that. I only want to pass in 8 bytes instead of the 50 bytes that's going to be necessary. Right? So, oops.
Why not do the same for date?
You could. I would have to go back here and redesign this to be a dynamically allocated date instead.
And
That's it. Well, yeah, but then I would have to change all my other code because then I could no longer use, say in the demonstration here, I could no longer pass in D2. I would have to dynamically allocate it, meaning that I would probably want an initialization function. I would probably want a creation function that did all this stuff for me.
Yeah,
Right.
that's annoying.
And I don't want to do that for the demonstration. Now, in practice, I might do that, and I would prefer a dynamically allocated dates there. But in practice, I might just use the built-in date time functions in C anyway. So that looks good. I do need to copy all of this stuff over to my header file. And of course, what else should I do? Documentation, right? And what else do I have here? Init film. I need to make sure that that's in there, but I'm not going to use it, so it's not that big of a deal. There we go. To do, cleaned it up, documentation. And over here in demo, I can now print this stuff out. Print, what was it, F1? It was cats. Apocalypse Now. What happened to cats? Oh, okay, cats was just the last one, okay. There we go. All right, so GCC film.c, and of course, compile it, and don't forget your WAL flag, right? Implicit declaration of printf. Oh, I'm glad I used the WAL flag. Why? What do I not have up here? std.io, right? There. Okay, now I've got everything. So GCC, it would have still worked, it's just that it's way cleaner to do this. And then demo.c, print film. Did I not do that? Oh, there we go, print film. There we go. And run this, and we see Apocalypse Now, Star Wars, cats, with the full dates that I defined up here from last time. Right? Nice convenience function, except wait a second. The second convenience function we were talking about was a way to generally provide a string representation of a structure. Is there a way that I could maybe combine those two and not have to do as much work? So what I mean by that is we'll go ahead and create a function called film2string, right? That takes a film, right, and gives you a human readable formatted string that looks kind of like this. Right? In fact, it'll look exactly like that. Char temp. I'll create a temporary string here that's large enough to hold any reasonable title. 1,000 characters minus 1 for the null terminating character. The date is always ever going to be 422. In fact, we didn't, right? If I want that leading 0 there, what could I do? 02, 02. And if you have any, any that were created in AD 800, you could of course go 04 here. I'm not going to go that far though, to ensure that there are 4 numbers there. But I want that leading 0 on that 8. Okay. Oh, they're not both 1979, are they? Were they released on the same date? I think we looked that up. No way. That does not seem right. I must have the wrong release date for Apocalypse Now or Star Wars. I'm pretty sure that this is correct for Star Wars. It was a summer release in... No, this is not. This should be 77, right?
And I think that you remember saying in May too.
Yeah, May something. I don't know. 15th or something. I don't know. Somebody can look that up and tell us. So I just wanted to make sure that we have a distinction here. But in any case, I'm going to create a temporary string here to hold any reasonably long title. And we'll forget about that endline character there for a second. I don't want to print it to the standard output. I want to print it to this string. Is there a function that'll help me with that? So printf prints to the standard output. fprintf prints to a file. If I want to print to a string, there's this sprintf function. And all you need to do is provide the string that you want to print it to. It'll take this, format it, provide the null terminating character for you, assuming that this is large enough to hold the result. If not, then it's undefined behavior. And then now, can I return temp? This is a good question. Thank you. May 25th is the correct stickler for correctness here. All right, May 25th, thanks. Can I return that string? No, this is a statically allocated string. It is created on the stack. So when I return to the function, that stack frame gets popped off and destroyed. What I need is char result. Result. Right? And now I can dynamically allocate enough memory to hold that string. Malloc, I could put in 1,000 times size of char, but if I don't want to waste space, by pre-formatting it using a temporary string here, I can go with strlen of temp plus 1 and make sure that your math is correct by putting the proper parentheses. So by using this temporary space here, I don't have to go through and count, okay, well, there's so many characters for the title, strlen of title, then a space, and then a opening parenthesis. This will always be 4 years, then another, 1 more, 2 more, 3 more, and then 2 more and 2 more, right? Do all the math manually or whatever. I don't have to worry about that because I've used a temporary string here. It's just a trick. The risk here, of course, it's a give and take. It's a trade-off. By saving myself some work, I've also made this code a little bit more dangerous because if we ever do have a film with more than 1,000 characters in its title, then we're screwed, right? It's going to result in undefined behavior here. Right? But it's okay. That's a risk I'm willing to take for now. You could be safe, or you'll be sorry, certainly, right? So now what I want to do is I want to modify print film to take advantage of this. I don't want to have to repeat myself with that formatting right there. So print film could call film to string, right, of the f, and that's char star s equals that, and then I just print out the string, adding that endline character right there for me, right, and then return. Okay. I need to make sure that this is my header file here. There's still a problem with it, but it's a hidden problem. And I'm going to ask you what it is. Good. Oh, what's wrong? I returned temp. Result. That's not the problem I was thinking about, but that was definitely a problem. There we go. And there we go. And we'll see that the behavior's not changed, or it is changed. What did I forget to do? Duh. That's another problem, but it's not the one I was thinking of. I need to copy into result the value temp. Then I can return it. Right? There we go. There we go, and run it there. We get the same behavior as before. In fact, if you wanted to, you could even make this a little bit more fancy. If you want to columnize this, you could, of course, have it adjusted to the left by 20 and padded out with 20 spaces. And when you do that, it's going to look really nice and like a column, like you'd see in a table. Right? All the dates are now aligned. If you want to get fancy, that's up to you. Okay? But the problem is what? Focus on this function right here. I create a dynamically allocated string representation of my structure so that I can print it out. Then once I'm done with it, I just return. What's the problem here? Let's find out if Valgrind has a problem with it. 6 errors in 6 contexts. 222 bytes, and that's just those 3 films over here being created and then not destroyed down here, but that's not that big of a deal because that happens in main. But there's definitely a problem in this print film here. Let's see, where is it? Create film, create film, create film. Film to string. What do you do?
Since it's a void function, you're not returning it.
Well, that's okay. But what am I not doing that I should be doing? You created this memory as a string representation of your film. What happens to that memory once you leave? The mess is still there. Free it up, right? Now that's a lot better. Now, before it was 6 errors in 6 contexts. Let's see how many errors. There's still going to be some errors there, or it thinks that there are going to be errors there, but there are going to be fewer of them. Well, okay. Not fewer, but it should be fewer bytes. But in any case, film to string, I cleaned that up. I don't know why you're complaining about that now. Oh, because I never recompiled, duh. Okay. Recompile that, then recompile that, then run Valgrind, and there should be fewer errors. There, I got rid of half the errors. Right? The half the errors were the 3 print functions. Right? The 3 calls that now I'm freeing that up and it's no longer lost. All right? Excellent. What might a function that deconstructs it, destructs it, look like? Void, free, film, right? Now, should I pass in a const? I'm definitely going to be making changes to it. I'm going to be destroying it, right? So it can't be a const. Right? Could I just do this, free f, and then I'm done, return. Again, think memory leaks. What is a film? A film is a title, runtime, IMDb, and then another structure. I don't have to clean up that other structure unless I went with that alternative design and I had a pointer to it. But anytime you have a pointer, you do need to clean that up. So I need to clean up the title before I clean up the film, right? And free f's title, and then you can free the film. Now let's take a look at the main here. Once I've freed the film, free film, Valgrind will probably end up telling me that everything is all fixed now, that there's no memory leaks whatsoever. I've got to make sure to put everything in the header file, though, of course. Make sure to recompile both of them. Run Valgrind again, and hopefully I'm not going to get any errors at all. Any memory leaks, I should say. Okay? So that's what a free film would look like, a destructor. Right? Again, to-do documentation. Nice, convenient functions. What about in Java? Java, convenience functions. Right? Or methods, I should say, because we're in Java, right? So, yeah, let's go over to Eclipse. And remember that I do have a film, these were called constructors, right? That in Java, or in an object-oriented programming language, objects are constructed, right? I've got two constructors here, actually. I've got one that takes a title and an Internet Movie Database rating. These were all generated. And it's not going to be on this screen up here, but if you are running Eclipse, of course, you can go up to Source and then generate the constructor using fields. And this dialog box pops up. And then you can say, oh, I want a title and a release date. Right? Generate that. And it takes care of it for me, right? I don't have to worry about that. There it is. There's the generated code. Right? You can have multiple constructors as long as you have a different number or different arity of parameters, right? Because the compiler is able to figure out at compile time that, well, if you pass a string and a double, you probably meant this constructor right here. If you pass a string and a local date, you meant to call this constructor right here. If you pass in, or if you have two constructors with the exact same signature, that's going to be a compiler error. Because when the compiler goes to, well, which one do you actually mean? If you're going to give me a string and a double, there are two of them like that. It's ambiguous, right? And it doesn't like ambiguity, and so it's not going to allow you to compile, right? But in Java, creational methods are called constructors. Right? You can have more than one constructor as long as they differ in the number or type of parameters. Right? And you can have as many as you want. You can easily auto-generate constructor code in Eclipse. Right? All you have to do is go to source, then generate constructor using fields. Right? Really, really simple. Oops. Okay, oh, that's because it's going to the other line. There. Source, then generate constructor using fields. You can have constructors may call other constructors to avoid duplicating code. And what I mean by that, Eclipse is not going to do that automatically. For example, let me cut this down to only these two constructors. Right? Don't worry about the super for now. That was auto-generated. That's implicit. But this one, I have a title and an Internet Movie Database rating. This one, I have all four. So in some sense, which one of these is more general? The first one or the second one? First one, it's a little bit more constricting, right? Because you're only giving it a title and an IMDb rating. What is the default value for these other things? The runtime is not provided by this constructor, so its default value is 0. It's a primitive, so it can't be null. Right? But what about the local date? That is going to be null. The default here is going to end up being null because this is an object. Strings, the default value is null. Numbers, the default value is 0. Booleans, the default value is false. Right? So in that sense, this one is a little bit more specific because it's putting in default values. This one is a little bit more general because it takes all those values. Basically what's happening here is that I'm going to this dot, what was the other one? Runtime is equal to 0, and this dot release date is equal to null. That's implicitly what is being provided here. Yeah?
I thought you said that things like the title and the release dates couldn't be null.
If you want to write code to not allow that, basically. You'd have to write it that way, though. If title is null, now in Java, how do you do error handling? You don't return an error code. What do? Throw a new illegal argument exception. Right? You cannot provide a null title. There.
But I thought you said earlier like the private label sort of does that.
It is private, but that means the outside world cannot muck with it. F.title is equal to null. Inside the class, of course, you can do whatever you want inside the class. Right? I could reset it to null here if I really wanted to, but then that's on me because it's my class. I'm designing it. Right? If that's nonsense, then at least it's my nonsense. Right? It's my fault. But in any case, that's some basic error checking that I'll leave that in there just as a demonstration. But if I have 4 values that I'm specifying, I can go ahead and call this one with those 4 values, right? And what's the order here is title, runtime, IMDb rating, and then release date, right? How do I call this function though? Right? Now normally outside the class, I call new film, and then I would pass all of these things in, right? Title, then 0, then the IMDb rating that I was given, then null. But I can't do that because well, I mean, it can, but all this is doing is creating a new film inside of this function and then ignoring it because I'm not actually assigning it to any value. Right? What I want is I want this constructor to call that constructor over there. Well, I don't have a way of referring to film because it's the class. Instead, I already have a keyword that does that for me, this. So, how can you have one constructor call another constructor? By using the this keyword. Now, this is complaining because I have this code up here. In fact, let's look at the error message. Constructor call must be the first statement in a constructor. We have an existential crisis here, right? Does a film exist as of line 11? I'm in the the film, I'm in the process of being constructed. I'm not constructed yet. So I can't have any other code until I am fully constructed, right? I have to call, if I'm going to call another constructor, I have to do it first, right? And then of course, this is after the fact here, right? I don't want that I can't check the title until after I've constructed it. Well, that's fine. I can just move it over here to this function instead. And that's where the error handling should be anyway. So constructors can call other constructors. Constructors may call other constructors to avoid duplicate using, oh, sorry, I already did it, using the keyword this, right? Okay. By default, if no constructor is defined, then a no argument default constructor is provided. It's kind of like a lawyer, right? If you can't afford one, one will be provided for you. If you can't afford a constructor, one will be provided for you that sets all member variables values to defaults, right? Zeros, null, false, right? For Booleans, defaults. So you don't have to have a constructor, right? I can prove this to you by simply getting rid of all these constructors, right? And the class is just happy about that. It's fine, right? Although these things never get set, so careful there, right? But over here in demo, if I didn't have a constructor at all, then of course I would only be able to use the default constructor, the no argument constructor. We call it the no argument constructor because there are no arguments provided to it, okay? But we do want our films to have titles and run times and release dates, etc. Okay. What about these other convenience methods that we were talking about? You can create an initialization function. There's no such thing. There's just constructors and multiple constructors. A way to print the structure to the standard output. A way to generally handle a string representation of that. And a way to free up that structure. So yeah, go ahead. Because of the types, right? The release date is actually a local date. If I had 2 integers, of course, that would be ambiguous. And that's why you wouldn't be able to do that. Like when I had 2 copies of this thing, right, it's not going to allow any constructors with a string and a double, and then another constructor with a string and a double, right? It's not going to allow duplicates like that. I mean, you don't have to do any error at all, checking at all if you really don't want to.
Well, no, I mean like the first one you have at the top there. You technically don't have to do that, right?
No, you don't have to do any constructors. The default constructor is maybe how you want to handle stuff, right?
Alright, but for other things, you would.
It all depends on how you want to define and design your class. Right? There are lots of other ways of designing classes. You can follow. There's a whole book on patterns that you can follow on class design, but we don't want to get into that yet. All right. So there are the other convenience methods. What about destructors in Java? Question mark? Do you actually ever free anything up in Java? Nope. Do not exist. And happily, because there's no memory management. I can't believe that it actually, all that was a semicolon and a parenthesis, and I'm going to be very interested to see if that happens on GitHub, if they interpret the smileys and emojis as well. Probably not, but it'll be fun to see here. Say what? Yeah, wow. I wouldn't go that far. All right, so what about a printing method? Well, I'm going to skip that and go right to the string representation method. So you can go ahead and create a public string toString, right? Where you return, this dot title plus space, and then in parentheses, this dot, what was it, release date? There we go. Plus, and then closing parentheses here, except that I didn't define, date, month, year. This also has a toString method defined. Any object worth its salt is going to have some sort of toString method defined. And this is built into the Java time library, so it's taken care of for me. Right? Oops, there we go. All right, let's go ahead and try it. Let's try to print out this film cats, system.out.println. I didn't define print to the standard input. All I had to define was a toString method, and it takes care of the rest for me. It automatically calls that method, right, and produces this result. Right? I didn't specify that it was, date hyphen month hyphen or year hyphen, etc. Right? That was all taken care of by this built-in class for me, because somebody wrote a toString method inside that local date class. If I wanted to, of course, I could go ahead and muck with it, and I only want the year, right? Dot, what is it? Dot, get year, get day of year, get year. There we go. I only want the year. Run this again, and I only get the year. Right? So you could do it manually, or you could just choose to use the default toString values. By the way, I like this one, but if I didn't want to have to type my own code, go up to source, generate toString. Well, what do you want to include in your toString? I'll include the title and the Internet Movie Database, and the release date. There we go. Generate. And it takes care of it for me. Now, it's not very nicely formatted, right? It actually has title is equal to title, then release date is equal to this, but at least it gives me a start, and I don't have to type everything from scratch. It's not the same formatting, but I don't like that formatting. So you go and you start mucking with it, and you just have, well, I just want the title, and then the release date, blah, 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 right? Whatever you want. But you don't have to generate it from scratch. I do like this, so I'll leave it. And of course, you can't have two string methods, so I'll just keep that one. Okay? So, all objects have a toString method you can define. Right? By default, if you don't do this, you can still print stuff. What if I didn't have a toString method over here at all? I'm going to get rid of it. I can still print it though. What is it going to look like? Garbage? Film at 4B1210EE. Run it over and over again, it'll be the same thing. What do you think this is right here? That's a Java virtual machine memory address, right? By default, it'll simply print the memory address. By default, it prints the Java JVM memory address. Right? You can override this functionality by defining your own method, right? Or use Eclipse to auto-generate your code. Okay. What else? A function to free it up. No, we don't need that. We don't need a print structure. But there are two other things that are really important in Java. When objects are, or classes, I should say, classes are used in standard collections. For example, a list or a set or whatever else you're going to use, a map, right? Often it is required that they define properly have properly defined hash code and equals methods implemented, right? Now the defaults here are, if I print out a hash code, it's going to be based on the Java virtual machine memory address. If I call an equals method, it's also going to be based on a Java virtual machine memory address. If you want to, you can have them look very, very different. For example, and on here, I'm not even going to bother typing it out because I've shown you this trick to you now. I'm going to use it. You can have equals and hash code, right? And I want it based on all of these things. If I just wanted it based on title, then what would it look like? It's auto-generated code, so it's kind of long, but at least it's based only on the title's hash code. And whether or not, and this film is equal to this film if they have the same title. Of course, they could have this different release dates, Star Wars 1977, Star Wars re-release 1997, special edition or whatever, right? They have the exact same titles, but different years. They would still be equal. Right? And as far as a set is concerned, they would be the same thing, and so it would reject that second one out of the set. Right? If you're searching through a list and trying to find something, it might use the equals method here to determine, I found that needle in the haystack. Again, it depends on how you want to define your object, how you want to design your object. I'm just going to go ahead and leave it off, but I've showed you how to auto-generate that. Right? Another convenience methods are getters and setters, right? Or mutators, right? Or accessors. Right? So from outside the object or the class, you may want to get an individual member variable, or the value of, get the value of an individual member variable. For example, when I was working with the toString method over here, right? Oops, I got rid of it. There we go. There it's restored. I said, well, I want the full release date, the year, the month, and the day. The second version that I did, well, I just want the year, right? This is a getter, right? Get the year of this object. Likewise, we can design our own getters here. That's a little bit too much. That's not going to show up. There we go. I want to get the title because over here, I don't want to print out the whole thing. I just want the title. Well, if I just try to get it directly, it's private. I can't do that, right? So I want a getter instead, get title. Well, unfortunately, that's not defined. So, okay, fine, let's define it. Public string get title, and then it returns this title. And now it's fine over here. You can go ahead and just print out the title if you want, or print out the individual year, right? Or whatever. Okay, that sounds like a great idea. I just need to do it 1, 2, 3 more times. Or do I? Go up to source. Generate getters and setters. Right? Expand all these out. Generate all the getters. Right? And it's not highlighting title here because it already to text that I already did it. Right? So let's generate those, and I don't have to type a single line of code. Getter, 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 getter. Right? What about setters? What if I wanted to change the title? F.set title to cats with a K instead. For some reason, I want to do that. Right?
You definitely fit the quality of that.
Misspelling, yes, exactly. So what would that look like? Public string set title, and then it takes a new title, or title, And I can say this title is equal to the given title, right? What are you complaining about? Oh, public void, because it's a setter, right? It's not going to return anything. And now, I can see that this has an effect. The first time is going to be cats, and then the second time is k-cats, right? That makes your objects mutable, changeable. That's why these are called mutator methods, right? Mutators, setters, allow the outside world to change a class's member variable values. Right? Only do this if you have a very good reason to do so. Right? And again, if you wanted to, you could auto-generate that. You could the same tool that I used, generate getters and setters. You can select all the setters if you want to. Only do this if you have a very good reason to do so. In general, you want to prefer immutable objects. Right? There is no setter for strings. There is no setter for local date. There is no setter for a lot of classes. Why? It's not a good design decision. Right? If you have setters, then that means that anybody can change your class, right? Now I could say that, I'll set the title to null. Titles can't be null, but in this case, I'm allowing it to happen because I define my setter. Now you can always go back to the setter and do your error checking there as well, right? If anybody ever tries to set this title to null, you can't do that, right? And we'll see it there. You cannot provide a null title. So you do have some control if you want to, but you know, why take that? Why do that at all? Just make your objects immutable. Have getters, great. Allow people to access those variables. No setters, don't allow them to change the variables. Allow them to create the variable, create a film through the constructors only. Right? Very, very good design principle to have immutable objects. And again, why do we like immutability? Because immutable objects are automatically thread safe, right? And every environment is now a multi-threaded environment, right? Okay. Let's see. Good. We made good time. The last thing that I would note are arrays or collections. Arrays of structures, right? Collections of classes, right? So just as an example here, I don't know. Let's talk about arrays of structures in C, right? So if I wanted, say, 3 films, right? I already have 3 films, but I want to store them not as 3 variables. I want to store them in an array of size 3, right? What would that look like? Right? Let's go back over here to the demo. And I've already created my 3 films here. What would it look like? Film, star, and I don't know, films, all right, plural. That's my films array if you really wanted to. I'll just call it films, right? Is equal to a call to malloc, right? All you have to do is think of this in terms of integers. If this were an integer, it'd be int star and then a call to malloc. What else would you want? If you want 3 films, or if you want 3 integers in this case. Size of int times n, right? Now, how does that change if it's not integers, if it's films? Film, film, film. And now you've got an array that can hold 3 films. 3 film structures, okay? How do I assign the first one? Film sub 0 is equal to F1. Oops. Films sub 1 is equal to F2 and F3. Is this going to compile? Question?
Why is it not double pointer because it's pointing to
Hold on to that thought. I'm going to show that to you in a second here. This is 3 film objects, right? Just like, I mean, if it were an integer, right? Int, int, int. Then I've got 4 bytes, 4 bytes, 4 bytes, all contiguously allocated. Right? Now that I've got a film, though, I've got this film structure, which say is 50 bytes or something like that, then another 50 bytes, then another 50 bytes. It's all contiguously allocated, right? It's the same as an integer array. Now it's a film array. But these 3 lines are wrong. GCC. Exactly. F1 is a what? It's a film pointer. This is just a regular old film, right? So, films is a film pointer, right? Film pointer. Right? Now, if I index it, films sub I or film sub 0 is that's like dereferencing it. That's a regular old film, a regular old structure, right? Film. So how do I, but F1 is a film star, right? A pointer. How do I make this compatible? I have to take the film star and I have to make it into a regular old film so that it could be assigned. Star, star, and star. And now the compiler is happy with this, right? Well, we'll get to that in a second here to resolve still an issue here, right? I'm cleaning these up down here eventually, but I do now have 2 copies of the film, right? Because what happens when I dereference it, I've got the film right here, and here's my pointer to it. By dereferencing it, now I've got a regular old film. I'm setting that film equal to this film, meaning it's doing a copy of those 50 bytes or whatever it is, right? So I actually have 2 films, 2 CATS films here, right? The way that I can resolve this is an alternative. Right? Let me go ahead and get rid of all this, but I'll keep it so that it's in the notes. Right? I could have, as you asked, films. Now what this is it's an array of pointers. Here's the first pointer, it points to this film over here. Here's the second pointer, it points to this film over here. Third pointer, and these films do not have to be contiguous one after the other anymore. They could be all over the place. In fact, they are all over the place right now. What does that look like? It's a film. It's not a 2-dimensional array of films. It's still a 1-dimensional array of films. It's just a different representation of it. It's using the pointers instead. So star, malloc, size of film star times n. There we go. And then film sub 0. Now I don't have to dereference it anymore. F1. 1 and 2. I don't have to dereference these anymore because they're compatible. This thing over here on the left-hand side, that's a film star pointer. The thing on the right-hand side is a film star pointer. I have to be careful now, though, because now that I've got a pointer to films, well, I guess I can do the same things over and over again, but this is going to be films sub 0. Yeah, I can do that. And then films sub 1. And of course, I could put this into a loop instead if you really wanted to. And GCC. Run it, and you'll see the exact same behavior. Okay? So here's an alternative way of doing it. All right, and now there's a third alternative way that I'm not going to go over because we don't have time. Read the book. I go over all 3 of these scenarios. So the first one is where you've got, the first one up here, is where you've got contiguous film, and it's all one big giant array. Right? No pointers at all except for the pointer to the first one. The second alternative here is an array of pointers. So think of it as a vertical array. You've got a pointer here that points to this film over here. You've got a pointer here. The second one points to that film over there. Right? There we go. that film over there. These films can be all over the place in memory. The third alternative is where you have an array of pointers, each one pointing to a contiguous allocation. Right? That's the best of both worlds, in fact. Because now you do have contiguous allocation on all your films, but you're referring to it through pointers. That way, if you need to swap these 2 things because they're out of order, because CATS comes before Star Wars when you sort them in lexicographic order, then you don't have to move this 50 bytes over to a temporary variable, this 50 bytes over to this variable, this 50 bytes over back over here. All you're doing is exchanging pointers now. Here's CATS, here's a Star Wars, they're out of order. So just simply change this pointer to point over there, change this pointer to point over here. and you never moved any memory at all. Right? So if you're interested in that way of handling structures, read the book. I've got, or watch the videos, because I think I do it in the videos as well. Right? None of these issues are an issue in Java. Why? No pointers, right? It takes care of it for you. Right? Yeah?
Why did you have to change with the print film? Why did you have to change them from F1 to
I didn't. I could have left it. I'm just demonstrating that F1 and films of 0 is the same thing. It's still a pointer to a film. I don't have to worry. If I did something like this, like this one up here, then this would end up not being a pointer. It's just a regular old structure. So if I wanted to print it, I would have to change it back into a pointer by putting an ampersand in front of it.
Yeah, that's confusing.
Well, it's 6 of one, half a dozen of another. Right?
Yeah.
It's more work to do it like this, and you have to redesign everything. But this is ultimately this is going to be like a little bit better. Right? It's more flexible, I should say, right? Because now you never have to move anything in memory at all. This can stay in memory. This can stay in memory. Where it is, it'll always stay there, and you only ever manipulate its order by manipulating the pointers to it.
And I'm assuming you would also have to free the films.
You definitely have to redesign everything like free and print and all that stuff to take into account the different way of representing this stuff. Right? Really quick here, how would you do stuff like this in Java? Well, you don't have to worry about it, right? F1, F2, F3, cats, Star Wars. Yeah. What did I just watch? I don't know. I'm not confident in my ability to spell it correctly. That's why I was looking for another title. But you can, of course, have a list of films, right? Films is equal to new array list. Right? Just like you've had lists of integers or lists of doubles or whatever. Of course, you do have to import these things. And then you can add them, films.add F1, F2, F3. Right. And now you can print out an entire list of films. System.out.println films. Of course, it'll format it like a list. So it'll call the toString method that you defined, comma, toString method, comma, toString method, and then put these square brackets around it. If you want a different way of printing a collection of films, then you need to write your own method. Right? This is what you get for free. Okay? Any questions on encapsulation so far?
Could you make a note of the method in the notes?
Yeah, I'll make sure to copy over all the code at the end of the day here.
Oh, so like even though we didn't go over the method in class, you'd still...
Oh, well, that you'll have to look at the book.
Could you at least make a note of like look for...
Oh, sure, sure. Third option, third alternative, see the book. All right. It's the right price too. Have people been reading the book, or hopefully? Sometimes. All right. In the main section, I use, well, this semester I started using zyBooks, which is an interactive book, to the only reason I've never had a paid for book before, simply because I don't believe in forcing students to buy, the latest edition for $200, $300. That's why I wrote that book to begin with, to give you a free alternative. But the main section, I adopted zyBooks this semester because nobody ever reads the book. Nobody ever reads the required reading. zyBooks is an interactive online book that forces people to read because it's graded. So you read a section, then you answer a really simple, easy to answer quiz at the bottom, and that's how we check that you read it. Right? It's okay. I don't know if it has had the transformative yeah, the transformative, impact that certainly companies claim there is, but it's been okay. But I have not adopted that for this section because that would require getting you like 2 books, one for Java and one for C. Right? And that's why I wrote it in the manner that I did, so that you also know that there's a PHP section. I once had somebody that wanted to collaborate to write a Python section, and then we could do a C# section or something like that, but I never got around to it. All right, then I will see you on Thursday when we'll start talking about recursion, very briefly about recursion, because the way that I generally present recursion is, here's what recursion is, here's how you use it, and here's why you don't use it. Right? And here's how you get around using it.